monotone or monotonicity talks about whether something is constantly increasing or constantly decreasing. So if we're talking about a sequence, we would say that it is monotone increasing if each subsequent term in the sequence is bigger than the term that came before it. So in terms of writing that out, we would write that as a sub n is less than a sub n plus 1 for all n, or in other words, for all terms in the sequence. Okay, similarly, we would say a sequence is decreasing if each subsequent term in the sequence is smaller than the one that came before it. So we would write that as a sub n plus 1 is smaller than a sub n. Okay. This is something that you're going to see come up again in the alternating series test that we're going to study a little bit later in this chapter. So this is kind of something you want to tuck away in the back of your mind so you don't forget how to do this. You can also use the first derivative to show that this is increasing or decreasing. That's something that you learned in Calc 1. So we'll go ahead and review that, but hopefully you remember that pretty well. All right, so we're going to take a look at this sequence here, 1 over the square root of n. I'm going to show this both ways, both using the sequence of inequalities as well as using the first derivative. So we're going to start out using these inequalities. And the way that I'm going to show this is I'm just going to plug some numbers in. So I'm going to use n equals 1, n equals 2, n equals 3, n equals 4, and kind of look, plug those in and look at how they compare to each other. So my terms in my sequence are going to be 1 over the square root of 1, which is just 1. And I have 1 over the square root of 2, 1 over the square root of 3, and 1 over the square root of 4. All right, so each one of these is smaller than the one that came before it. And so we would call this decreasing. Okay. This isn't a very formal proof, but it is fairly commonly accepted in sequences and series, and this is often how people use this when they do the alternating test. If you wanted to do a little more rigorous approach, we use the first derivative. Okay, and in order to remember that a sequence is a series of dots, so we don't have continuity, so we do need to write this function as a function of x so we can take the derivative. So my f is going to be x to the negative 1/2, which makes f prime equal to negative 1/2 x to the negative 3/2, or negative 1 over 2x to the 3/2. Okay, so x to the 3/2 is always going to be positive, and so we have a negative divided by a positive, so this thing is always less than 0. And what we know about the first derivative tells us that this is a decreasing sequence.